the Hi everybody, welcome to the Distinguished Linguist lecture series at V-NYI number 8. We are delighted to have you all here today, and we're very happy to have Hongchen Wu with us, an old friend of NYI, both in-person school and virtual school. She has been at both. Hongchen is assistant professor of Chinese in the School of Modern Languages at Georgia Tech University. Her research has mostly been about Asian languages, and when I remember her at Stony Brook, she was working on Chinese syntax primarily, with a fascinating dissertation on quantifier scope in Chinese. She's also worked on WH intermediates, polarity items, syntax semantics interfaces. Now she's moved also into working with students on more interdisciplinary projects, and that's what we're going to hear about today. She also is involved in NACLO, the North American Computational Linguistics competition that is held at various places around the country. She's organized that at Georgia Tech, and also has a podcast, Stories of Languages and Linguistics, that she has launched. She had her PhD with us at Stony Brook in 2019, and we miss you. But we're very proud of you, and it's fantastic. And today she's going to tell us about her most recent work, which is using a forced aligner for prosody research. So please welcome Hongchen Wu.
Okay,
Take it
thank
away.
you. Okay, thank you, everyone. It's very good to see you all. Hi, Vinny, do you think I can share the screen? Okay, great. I can share the screen. Perfect. So, yeah. Thanks, John, for giving me this opportunity to talk with you. I'm always a big fan of NYI, no matter when it was in person or now it's online. So thank you for all coming here. So as John just mentioned, this is my recent work, and it's a kind of like a new branch I developed last year. It's still related to my concentration on syntax, semantics, and prosody interface, because as you see in the title, that's the use of forced aligner for prosody research. Then why I got into this, I will explain in a little bit. But I want to first to tell you about our team on this work. So I started this project and with 3 students assistant who were originally recruited to help me with the annotation of the prosody work project. But then later on, I realized, oh wait, I should really start doing research instead of just getting the annotation done. And then I started this project, and then we also have Professor Jiwen Yun from Stony Brook joined us, and then we 5 worked together last year. And also, actually, this project started around the summer 2022, and the paper was published July 2023. Okay, so then when I mention annotation, you would expect some of you might not so familiar with what a data annotation would mean to for a speech or for prosody research. By prosody, I mean as like a specific sense I will explain, but speech in general is about audio files, right? So when you have audio files, if you want to analyze, for example, a people's intonation and whether they have the certain stress on something, or whether they have the like duration of a certain word is longer than the others, all of this information need to be extracted from the audio file. Then how are you going to extract this information, which requires annotation? The annotation means that you need to have time aligned segments, which means, for example, this time, right, this area, then you will have this then this means this, and across to this part, this means is, and then test. So once you have this time-aligned information, then you can extract, the duration of this consonant, or the duration of this word, or the intensity, or the pitch, right? All of these we call acoustic features. Okay, and then most of the time we use Pratt. Okay, these are two Pratt logos. On the left one is the most recent logo for Pratt, which is a computer program to help you do the phonetics and phonology research. Okay, this is the annotation. Then the problem is that, as you see here, this is just one sentence. This is a test. As you can count here, you need to add, if you do this manually, you need to at least draw the lines and listen to the audio over and over again to get the boundary correctly. And it's like this one sentence might take you at least a couple minutes. So manual annotation of audio files is very tedious and resource consuming. It's not only like a human resource consuming, it's also like a time and money resource consuming, because often the case we need to recruit annotators to help with the annotation task. So according to the previous research, like one of the documentation, the 1 minute audio file might require around 13 hours of annotation work. It's just a lot. I remember when I was a graduate student doing some Prosody research. It took me like hours long sitting in front of a computer and just do this annotation one by one, hand by hand. So, and often the case that like we still also need multi-annotators to work on this and try to compare the inter-annotator agreement to avoid human annotation errors. So quite a lot. Then to give you a kind of like a more concrete idea on how tedious this manual annotation would be is, for example, you have 10-minute production audio file per participant, which is a kind of like for a production experiment. It's a very common, like 10 minutes. Then you have 10 participants. Then this will give you 100-minute audio files. And then according to this documentation and also my personal manual annotation experience, it will take you around this many 1,300 hours of annotation. And if you divide it by 40 hours per week, then it's 32 weeks almost per annotator. If you have 2 annotators working on this, which means these 2 annotators will have to do nothing else but only this one for 60 weeks to get all the annotation work done. It's quite a lot of like work. That's also part of the reason I have to say the speech production research have been really kind of like a slow process, as well as it's a quite demanding process for researchers. Then, yeah, then one day I was so annoyed by manual annotation, and one day I was like, at that time, actually, I already heard of something here and there about, oh yeah, we have automatic speech recognition techniques. As you guys would probably know from your smartphones, right? You say something and you ask Siri a question. Oh, hi Siri, what's the weather? And then Siri would understand. This is, you get the speech there, and Siri has this automatic speech recognition, and they have the phonemic dictionary and transcript and automatic model, and then they just processed it to index the speech, and then it printed out on the phone screen, say, oh, what's this weather? The weather is blah blah. So since we already have this kind of techniques, then why can't I use this for Prosody research? Then that's kind of like the initial motivation. And then force alignment. So force alignment is a technique like which is part of the automatic speech recognition. We call ASR techniques, right? It's a technique that takes an orthographic transcription of an audio file and generate a time-aligned version using a pronunciation dictionary to look up phones for words. Okay, so this definition is the definition I directly copied from the Montreal Force Aligner website. And the picture showing here is this Montreal Force Aligner founders. They first presented their work at the LSA Linguistic Annual Meeting, Linguistic Society of America Annual Meeting in 2017. So basically, was this false alignment technique can do is like I give this program a transcript, like please say buzz again, this is a transcript, and I give them a dictionary, say please, the dictionary is police. So you have this dictionary, and then I give the audio file, and then the computer will give me the output on the right, which is aligned, time aligned text grid file, which can be directly used to process with the Python, and all processed by the Prat, which is the programs we often used for phonetic research. And then there are so many false alignment tools. So when I started this project, I was thinking, okay, if I want to really look at when I get into this essay, I want to use false aligner tools for my own Prosody research. Then I also, at the meantime, I do want to assess which one works best, and also want to see if there's possible to not only generate like, please say buzz again, this like a word by word or phoneme by phoneme boundary, but also can give me, for example, if I want a phrase level, I say please as the one phrase token, and say buzz again as another phrase token. Can this give me just like directly this phrase level element? So that was the intention. So I started research on the false aligner tools available, which is primarily open resources one. So at least 15 to 18 at the time when I started to look at into like around 2021 and 22. And then there were highly positive feedback on the performance of these false alignment tools, especially on phoneme boundaries, as I mentioned, on phoneme boundary. But for Prosody, which focus on superior segmental level intonation, which we don't really focus on phoneme level, we focus on phrase level, syllable level, right? And then all these existing evaluation on false aligner tools are primarily in for English, for other language, for like languages that don't really involve tones. And for why the tonal language make it a special case for this kind of study, because tonal language, which means you have lexical tones, then the lexical tones would, for each syllable, there is a specific tone there. Then this tone would give the stress, would change the pitch of the vowel, and then would kind of provide a challenge for how to use the false aligner tools here. So I started to, that was basically what I said, right? From this is the Prat visualization of an audio file. If I want to get a time-aligned results output, I want something like this one. But this one is manually, and this won't be able to directly processed by current false aligner tools according to their manual guide. So because they only give you the syllable by syllable level, but I want like the subject, which is 2 syllables, and then the verb plus aspect, which is also 2 syllables. So I want this like to be directly together, because when I do the Prosody, I focus on subject, the verb plus aspect, and the WH word, right? I want this one. So can I do this with false aligner? Is there any tricks I can do to make it work? So the present study is evaluating false aligners from the perspective of prosodic research for tonal languages, which has barely discussed in the literature. And I want to use this project as a kind of like a showcase of how to use false alignment in speech research that investigate superior segmental level sound information, and how to measure this performance of false aligners when applied to a tonal language such as Mandarin Chinese. Yeah. So then the tool and input that we use, as I mentioned earlier, there were like at least 18 open resource false aligner tools available. And then why do I choose this Montreal false aligner? Why do I choose this specifically? Why? It's not just because Montreal is a good place, a city. No, it's the reason is that this one has a dictionary, has like a Griffin G2P models and Altusi model and language models. So this one has a higher accessibility and then compatibility. It's open resource, it's free, which means, and it's keep updated, and also it can work for both Windows and Mac. And also it has pre-trained autistic model for 74 languages, as I checked yesterday. But at that time I started this research, I remember it was around 30 or 40-ish, like which was 1.5 years ago. Which you see, like it's evolved so fast. And now at that time I used Montreal False Aligner version 1, and now they already released, I think, version 3, like two months ago. Yeah. So and also this Montreal False Aligner has ability to train with other languages that are not included in their pre-trained models, which I will talk later, which that's also my actually like most recent research, like the next step after the one I'm presenting to you today. So then it uses more advanced autistic models based on chip phones, and it's built using the Coyote toolkit. If you're wondering what a Coyote toolkit is, you feel free to Google it. That's kind of basically a lot of false aligners, like the basic infrastructure. So it's offering advantages over other toolkits underlying the existing existing aligners. So the high positive evaluation result on this specific false aligner is a range. The accuracy ranges from 67 to 86, according to the most recent like evaluation report on like children's language or British English variations on different like other languages. But of course, there were very barely study on tonal languages. So after I chose this one, and then I start to build up the speech dataset, because if I want to have a very thorough evaluation on this and want to test if it could work for phrase level alignment, then I should have a really nice constructed dataset. And then, so we have this dataset is constructed by this way. We have 33 adult speakers of Mandarin Chinese, and then 15 of them recorded their speeches through their phones or laptops and submitted their recordings through emails. And 18 of them recorded their speeches in a soundproof recording booth with professional recording equipment, because we want to compare if like a recording quality would matter here, right? Because essentially we want to see, if a false aligner is really like intelligent, efficient, or effective enough, then you should be able to accommodate audio files with different quality. And then these speech samples were recorded based on 56 given target sentence. And why we like give this kind of like a target sentence to ask them to record instead of just record their natural speech? We have two like main kind of like considerations here, which I will explain in a minute. So the very first thing is the number of syllables in this sentence. We specifically range them. We range from 7 to 20, because we also want to see, because in general, a false aligner often the case that can't take longer audio files. It has to be very short. And we want to see whether the length would matter. And also we vary the sentence structure. If we record someone and say, oh, hey, can you send me a 10-minute recording? Then we might not be able to get varied sentence structures, right? Which means, because why varied sentence structure matters, because, for example, if it's an interrogative sentence and compared to a declarative sentence, you're going to see completely different intonation parting. And then also, when a sentence have like a long enough with different parts possibility, right? When you talk about relative clause, you often have a pause before the head noun, or a pause after the head noun, or a pause before the relative either. So all of these, so we want to vary the sentence structure as much as possible. So we have this like a target sentence we give to them and give them instruction, tell them how to record. And all these sentences, another difference is that all these sentences are potentially ambiguous. The good thing about this potentially ambiguous sentence is that like they have either can be understood as declarative or can be understood as interrogative. So why that matters? that's this way. I will talk in a second. So this is how I construct the speech dataset. And then after I received all the recordings, I somehow need to convert the audio file format using Prod because this false aligner only take WLV formatting. And a lot of like phone recordings submitted was MP3 or M4A. And then for the sampling rates of the channels, I didn't touch it at all because this false aligner by default taking the 16K hertz sampling rates. But I did coding these audio files when I received its audio files either from the lab or from participants' email submission. I chop these audio files by sentences and remove duplicates because these participants have chances to re-record a sentence if they think it's necessary, and will only tag the latest version of that sentence as the final audio in the dataset. And then I coded these files. For some files, for example, if the participant thinks, oh, hey, I don't think I can say this sentence based on the meaning or based on the instruction you give me, then I will just label that sentence into null. And if they misread that sentence, I label it as misread because essentially when I compare false aligner with the human annotation, and they have to be exactly like aligned with the same labels, right? Otherwise, it won't make sense because if a line boundary have different labels, then how am I going to compare the first boundary would match to the second boundary? And then in total, I got 4,096 audio files. It's about 260 minutes long. It's 1 to 4 seconds per file. There were 33 participants, but there were only 32 of them like complete the recordings. One of the participants' audio files were just excluded because I don't have the complete submission. So the advantage of this dataset, the first advantage is this dataset contains minimal pairs of naturally occurring ambiguous sentences that are prosodically distinguished. So although it's not, the dataset is not derived from natural speech like kind of our conversation, but it's naturally occurring ambiguous sentence like this one. We often use the sentence saying 中国队谁也打不过, referring like one way to say the Chinese team can't beat anyone. We refer to the Chinese male soccer team. When we want to use this sentence to refer the Chinese ping pong team, we refer to the no one can beat the Chinese team. So this sentence is kind of like ambiguous in 4 ways, and it's a kind of like a naturally occurring ambiguous sentence on the social media, and all the 15, 6 sentences we try to construct is we try to make it as natural as possible. And it's minimal pairs, as you see here. With why minimal pairs is great, as you see in this part. So these are the 4 readings of the examples, right? It's exactly the same input string, which is the linear string are exactly the same because the lexical item are exactly the same, but the prosodic realization are different. You already see the difference here. Like the blue line, right? The blue line refers to the pitch realization. The realization are so different. And also, as you see this alignment here, you see like duration, like this one duration for the WH word is much longer than other two. So the good thing is this ambiguous sentence share the same underlying phonemic tones for different meanings, which means we have same transcript, same dictionary input to this MFA, which is Montreal false aligner. But nevertheless, different readings have to be realized with different phonetics, which means if a false aligner is smart enough, right, they take exactly same transcript, same dictionary, but they somehow can still do a good job on aligning this because which means the false aligner can distinguish these different phonetic realizations. then this provide an excellent opportunity to evaluate how well this MFA Montreal force aligner can handle some departure in production from the expected dictionary pronunciation of these words. Because we all know, like in natural speech, we don't really like say any single word 100% to be the same as what it would be on the IPA format, right? The International Phonetic Alphabet format. No, like I say what, you say what. These two words are all what, but we say it definitely differently. So I want to see whether MFA can handle this, and in particular, because these sentences are potentially ambiguous, with the same input string, if MFA can align this correctly, then which means MFA also have some knowledge about to get to know these intonation patterns differently, right? As you see here, the intonation patterns, these 4 readings have different intonation pattern, like the 4th reading have an actual parse, right? If you see the blue line and the yellow line already tells you the difference on the pitch and the intensity as well as. So then the other advantage of this data set is this data set contains sentence level speech production with words. When we construct this target sentence to ask participant to record, we intentionally to include as many different types of words as possible. So we have the words like a neutral tone. You might be wondering what the hell is a neutral tone is. I will explain in a second. And what is a suffixation? These are particular Chinese prosodic, Chinese phonology terminology. This provides an excellent opportunity to evaluate whether the force aligner can correctly align sentences with various word types and words that have less silent or toothless features. Okay, then which already telling you what the neutral tone and suffixation is. So on the top, this chart shows you kind of like if you know a little bit about Mandarin Chinese has basically 4 tones. People will tell you, you often hear ma, 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 which is the first tone, second tone, third tone, fourth tone. As shown by these like lines, it tells you the speech patterns. But these dots, the dots here tells you how this neutral tone will be realized. So the neutral tone will be, if a syllable is realized as a neutral tone, then its pitch realization depending on its preceding syllable. If the preceding syllable is this one, is realized more like this. If the preceding syllable has a pitch pattern like the second tone, then this neutral syllable will the neutral tone of this syllable will be realized like this dot. So neutral tone has like a kind of like depending on the context. So if Montreal force aligner is really a good tool for prosodic research, then they should be able to handle this. And also on the bottom, this chart, I'm not sure whether you can fully see this, but nevertheless, if you just look at on the left chart, right? This the part I'm circling now. If you can see my mouse this moment, this is the second syllable of airplane in Chinese called ji. Okay, but on the right chart, if you also see the right part of the right chart, this is also the second syllable of the airplane, but with the suffixation, you add just here. So you see, once you add this, this is essentially just is one syllable. But once this is attached to the preceding syllable, it's kind of like a syllabization, which means it turns 2 syllables into one. And then you see these red dots on the left chart compared to on the right chart. You already see this like pitch realization are different and also duration are different either. So suffixation also kind of would the prosody realization would also give you different prosody realizations depending on the context. So if force aligner is smart enough, they should be able to handle this. Okay, and then this data set also is a very balanced data set. It's not only about how much like consideration we put to make it a sophisticated data set to test out this false aligner too, but also we want to make it balanced so that we can compare lab recordings versus non-lab recordings, which is whether the audio quality would matter. And also we have a similar amount of audio files from both female and male speakers. Okay, we have 32, which means at the end we have 15 males and 17 females. And then, so it provides a potential way to evaluate if the audio input quality and gender affect the alignment result, which these kind of factors are not really concerned or evaluated a lot in the previous research. So then the evaluation results and also how the evaluation process we did. So this is an example of syllable level annotation produced by the Montreal false aligner. Then how it's generated, right? It's give you the lower tier is the phone's level, the upper tier is the word's level label, and these blue lines and the yellow lines tells you the intensity and the pitch. And then, okay, it's this. So first you need an audio file, WAV format, and you need a transcript, something like the table 3, right? The transcript. I intentionally use the pinyin instead. Pinyin is a one-way, it's a kind of like a one way we do, we kind of record a Chinese pronunciation. I didn't use international phonetic alphabet. Why do the transcript as well as the dictionary? It was because at that time, I didn't know why the Montreal false aligner, somehow we had some issues if we input international phonetic alphabet. And also for the main reason is like pinyin is obviously much easier, like accessible tool for people to transcribe Mandarin audios, right? You transcribe Mandarin audios with the pinyin and which means just a romanized letter plus the numbers. The numbers indicate the tones, okay? And now you need to have a dictionary. At that time, when I used when we used MFA 1.0 version, which is in 2022, there was no like a existing Mandarin dictionary. Of course, now they already published a Mandarin dictionary, but at that time we generated our own dictionary, which is not really like a lot of work, because all you need to do is like you take a list of most commonly used Chinese characters, and which is keys, and you use some online tools to transcribe them into this pinyin, and then you need to have the values. And the values have a specific format, which is you need to have one space between each phone, and you need to have these tone numbers on the vowels part. Okay, and then MFA already have a Mandarin autosic model, so yeah, we just give the audio file, give the transcript, give the dictionary. Transcript and dictionary are in TXT format, and just one command line, MFA Mandarin autosic model, we call MFA align, and then we input all this information there, and we get that alignment result text grid file, the one you see here. Okay, it just generated this syllable level alignment like in a few minutes for hundreds of files. Okay, so then we want to evaluate the alignment result generated by this false aligner, right? We have 4 well-trained human annotators reviewing the boundaries produced by MFA and adjusting the boundaries and interval labels if MFA generated the boundary did not match the syllables as intended. As mentioned earlier, we have more than 4,000 audio files, which is more than 200 minutes, which is too much if we evaluate all of them one by one. So we randomly select 1,000 audio files and evaluated the syllable alignment results that MFA generated roughly around 27% of all collected data. If there's a mismatch interval number or level or in the human alignment and the MFA alignment, for example, MFA put some place saying this is a silence, but human thinks this is not a silence, this should be part of the previous syllable, then this is a mismatch. And for this kind of mismatch, we exclude from the final comparison for reasons, mostly for technical reasons, because with this kind of like mismatch labels, if we include in the final comparison, we somehow need to manually evaluate all of this, and that's too much work. But at the end, we didn't like exclude too much audio files, so it's still quite a lot to include in the final comparison. So the final pairs we included is more than 10,000. So we have 10,000 pairs, which means 10,000 data points to see the syllable level alignment performance. Okay, this one is the MFA generated. But as you can see here from your, like just look at this, you see obviously this is this part, the beginning part was like there was no sound really existing there, but MFA somehow have it's started much earlier than we would expect. Okay, and then on the right is the ones that we would make the human annotator would adjust, right? In particular, on this Li, right, Li3, and on this Li, you see the starting point are completely different. So this is how human annotator would adjust based on the MFA's result. And then later on, when we do the comparison, is okay, the left boundary for Li starting at 0.1 second, and for human evaluation result, the Li3 Li, this syllable, the boundary starts at 0.4 seconds. So which means there's a kind of like a 0.27 seconds difference there. Okay, then we record all this difference for each single boundary. Okay. Of course, we have a Python script doing this. We can't do this again manually. Yeah, so once you have this text script file, you just write a Python script, extract all these syllable like a boundary absolute difference. Professor Jun Yun is the ones who did the Python script. And then this is the results. We selected these 30 groups from different speakers, and this group 1, group 2, group 3, this kind of like tells you different groups have different sentence structures. And then the F in the parentheses means female, the male in the parentheses means male, the M in the parentheses means male, and the speaker 3 means just a speaker 3, and lab speaker 2 means this person is from lab recording, otherwise is from just a non-lab recording. And the accuracy presented there, it was like a 13.61 is the ones for we call average time difference, boundary difference, which means every boundary, how they differ, MFA and human evaluated result, how they differ from each other, and what's the average. And the one number in the parentheses means the standard deviation. Okay, this is by group, by speaker, but let's look at the general. So overall, all these 11,000 audio files we evaluated, average human MFA alignment differences being 15.59 milliseconds. So milliseconds is like 1 second is 1,000 milliseconds. Like, as you see here, it's like really small. But the standard deviation somehow is much larger than the average. Then this already like it's something going on there. It's a little bit. And then the average human MFA syllable level alignment difference of a group like ranges from 2.94 milliseconds to 28.58 milliseconds. Then this tells you there are some cases that MFA generated perfect alignment that human didn't even move or moved very, very tiny. But there are some cases definitely quite huge difference like the one you see here, right? And then, so we take a deep look at these, we call outliers. So we examined for one, there were 197 data points where the absolute time difference for a boundary is larger than 100 milliseconds. 100 milliseconds is a really silent difference because often the case 100 milliseconds will be considered as a silent pass already. Then most of these outliers involve the boundary for WH word, adverbs, negation markers, and words with third tones and neutral tones, and also start boundaries. So all this I will discuss more in the discussions part, but you already see something here. There is something related to the neutral tones there, which and then that was a numeric presentation, but we also want to do a statistical analysis. So we take the conventional comparison people did in the literature, which is we call it the gold standard. The gold standard means 25 milliseconds. 25 milliseconds is a threshold, which means if a false aligner or if another annotator align a boundary compared to another a second annotator, if this boundary difference within 25 milliseconds, which means our human ear probably won't tell that much difference, you know? So that's we often say 25 milliseconds as the gold standard. So within 25 if the difference are within 25 milliseconds, we think it's okay. We can give it a pass because we don't penalize, we don't want to be too harsh for these false aligner tools. To want them to be 100% accurate because even human annotators would make human errors, right? So we transform all the numeric time difference for each boundary using 25 milliseconds, the gold standard threshold. So if it's larger than 25 milliseconds, we put no. If it's smaller than, then we put yes. And then with this, then 73.49% of human MFA difference at this syllable level were within 25 milliseconds of the gold standard. So which means, more than 73% of the time MFA giving the exactly the same or at least very, very close, 95% close to what human annotator, well-trained human annotator would do. So then they're indicating a high level agreement, which means a high level accuracy. And also this 73.49% is close or higher than previously reported phone level human MFA alignment agreement rate. But as you see here, this is a syllable level alignment, right? It's not really phone level. We can't really make this direct comparison, but what we can reasonably conjecture is that syllable level, as I mentioned earlier, these Mandarin syllables have like either possible resyllabification or the possible neutral tones, or this would make it quite a challenge for syllable levels. So then we make this conclusion is that MFA can make decent syllable level alignment for a tonal language like Mandarin, okay? And then furthermore, with respect to this particular data set we craft for this assessment, MFA is established to correctly align audio files of ambiguous sentences with underlying phonemic tones, but different prosodic markings. So it's great, right? We can use that. But then syllable level is only the first level. Then how we want to do that? But we also, at the time, we also compare local recordings versus label recordings, right? So as you see, the average difference as well as how many, the percentage of the difference is within 25 milliseconds, you see label recordings are really have a shorter human and false aligner difference, as well as the label recordings have higher percentage of like differences within 25 milliseconds. Remember, 1 second is 1000 milliseconds, so 25 milliseconds is really short. Like we don't even like notice. So significant difference between the two local recordings and lab recordings on the 25 milliseconds threshold where a chi-square test. Then this tells us what? Tells us local recordings are feasible because it also give you around 70% accuracy. But lab recordings are always better. So it's kind of, it echoes what Sanker et al. Did research before, like compare local recording quality and this lab recording quality and how this audio recording quality would affect the speech research results. The picture on the left are mostly general setting that what a lab recording would look like. And then female recordings versus male recordings. So you see here, so female recordings and male recordings, very similar average differences and very similar percentage differences within 25 milliseconds. And as you would expect, there's no significant or statistical difference between the female recordings and male recordings on the alignment result. Then, yeah, we don't find any gender differences here. So we also did an efficiency test. And then how we evaluate the efficiency, because we did a 30-minute time test with 2 annotators. These 2 annotators use a different operation system. We want to estimate how much time people would need to spend on 1 minute audio file if they use MFA, and also how much work they can do within 30 minutes. So the result is about 30 minutes to 40 minutes, we can complete annotation with both phone level and syllable level information for 1 minute long recording. If you recall the introduction part, 1 minute long recording for the phone level annotation, you need 13 hours long. Okay, then it's really efficient if you use MFA. So then you would reduce your work from 32.5 weeks for 100-minute long data set for production research into 1.7 weeks. Okay, this is quite amazing with this efficiency. But, you know, we always want to be more efficient, right? Because with syllable level, yeah, we have the syllable level on the top, right? Which is the one highlighted with this red rectangle. But what I intend really want to get is the lower level, the second, the second red rectangle that is highlighted. What I want is, can I directly just get this? I want to have this subject. I want to have the WH word phrase, and I want to have the adverb. I want to have the verb phrase part. I want to have this phrase level alignment. Can I have MFA directly generate this, rather than I have to like, oh, MFA give me the syllable level, I still need to move the boundary, adjusting the level, the labels. I don't want to do that. Yes. So the first experiment tells us, okay, we can have MFA generate syllable level, and we adjust the boundary and adjust the levels, remove some boundaries to make it phrase level, right? Merge two syllables into phrases as what you intend to have for your Prosody project, and you get a phrase level alignment. But can we get maximize the efficiency to get a direct to reduce the intermediate 2 steps to have MFA directly generate phrase level alignment. Then I started a second experiment. Second experiment is since MFA takes audio file, transcript, and dictionary, and auto-sim model, right? So if you want the result to be a phrase level, you have to make something changes on the transcript or dictionary, because auto-sim model, neither auto-sim model or audio file can be changed, because that's what it is what it is. And then, so I started to have different variations of transcripts and dictionary play around. As you see here, these are phoneme by phoneme pronunciation dictionary, or syllable by syllable level pronunciation dictionary. And also you have phrase level transcript of syllable level transcript. I somehow mix all possible combinations and just take 4 or 5 audio files and do the workaround. After a couple round experiment, yes. So the one in the middle, this combination, phrase by phrase transcript plus the phrase level dictionary, which is the one highlighted in the green one, okay? And also this dictionary will be the one more like phoneme by phoneme pronunciation. So we have this combination yields the most kind of decent result based on this 4 different audio files. As you see, all the other 4 possible combinations give you really absurd results. And then I say, okay, then starting with this, can I do a large scale evaluation to really test if this can really give me the phrase level generation correctly? And then similar methodology as we did for syllable level alignment evaluation. We also have human annotators reviewing the boundary produced by MFA and adjusting the boundaries, interval syllables, if the MFA generated boundaries did not match the phrase as intended. And we use exactly the same audio files as we used for the syllable level. And then we applied the same data training process criteria here. And 354 audio files were trained. And this is largely because MFA somehow has this weird superior process intervals. And that kind of these issues has kind of been reported quite a lot by users of MFA. And then at the end, we have more than 3,000 comparison pairs for phrase level, right? You see, originally, if a sentence have 20 syllables, and if you do the phrase by prosodic phrase that you want to analyze, then you probably end up only 4 phrases or 5 phrases. So obviously, the comparison pairs would be much smaller than the comparison pair, the number of comparison pairs we see in syllable level evaluation. Then this is a result, the same formatting as we see for the syllable level boundary time difference. But let's look at the general results. The average human MFA alignment difference being 22 milliseconds, great, but standard deviation is still too large. So which means there are definitely some suspicious data points or outliers. And in particular, when you look at this specific speaker by specific group, there are one group you have 282 milliseconds average difference, which means that group literally MFA result was terrible. Now what's going on there? So we also looked into this boundary differences with that are larger than 100 milliseconds. There were in total 106 data points, and most of them very similar sense. Most of them have these extreme large human MFA differences, like 700 milliseconds, we completely the MFA got that wrong, and we manually checked and found it's apparent mistake. Although what causes that mistake is still a little bit unclear, but our suspicion was that it would be possibly with the audio recording qualities, because this is from non-lab recording and also from mail recording. Because male recordings tend to have lower pitch than female recordings. And then the phrase boundaries often goes wrong when they were involved in neutral tones and tone sending. Now, what is tone sending? Which means if two syllables adjacent to each other, and then in particular for third tones, often the first third tone need to be changed to a second tone or to a different one. So it's called a tone sending, which means these tone variations there. And then same thing, we use a gold standard to transform the numeric data to binary data to do the statistical analysis. And 65% human MFA difference at phrase level were within 25 milliseconds of the gold standard. So of course, this percentage is smaller than the 73% that we see in the syllable level, right? I think there are some reasons for this. One of the reasons is the data points comparison here is much smaller than the one we see for the syllable level, because when you have smaller data points, if like a small portion of these data points goes wrong, you somehow get this accuracy percentage will goes down quickly. And also, phrase boundary actually are often not easy because it involves super segmental features such as intonation, pitch variations. These are very complex. But nevertheless, this 65.57% accuracy or agreement rate is still even higher than some previous reported phone level alignment rates. So it's a pretty decent level. Then, which means great, MFA can do phrase level alignment. We have maximized the efficiency. Then let's look at the local recording and lab recording difference here. So local recordings, obviously you see here lab recordings yield much better alignment result. Again, it echoes what we found for the syllable level alignment evaluation. So a more professional recording environment is preferable when recording prosodic phrase boundaries, when researching prosodic phrase boundaries. So again, if you want to do prosodic research, and we suggest you use the professional recording environment. But the interesting thing is here. For female and male, if you recall the syllable level alignment evaluation, we didn't see gender difference at all, right, with respect to alignment performance. But here, we have a gender difference. The male recordings have much better alignment rate, or we call alignment accuracy, than male recordings. Okay, there's also significant differences there. So our explanation for this is that since prosodic boundaries are sensitive to super-segmental features such as pitch and intensity, we conjecture that the dictation of prosodic boundaries is challenging when the voice pitch is low. Like in general, male speech has much lower voice pitch than females one. In particular, when the male speech is recorded with non-lab recording, which is the audio quality is not good, then that will yield even worse alignment performance. Again, then this tells prosodic researchers if they want to MFA, use MFA to annotate their data, and they want to study these prosodic features there, they should really consider the professional recording environment. But of course, the non-professional recording environment also give you really decent alignment accuracy. Okay, then we also test out the the phrase level annotation efficiency is as a typo here. But anyway, same methodology as you see for the syllable level annotation efficiency. And so about 30 minutes to complete annotation with phrase level, phone level info for 1 minute. It's like a little bit quicker than we see for the syllable level alignment. But our human annotator who did this efficient test told us that they both of them saw a phrase level MFA alignment was better for improving annotation efficiency for prosodic project that requires phrase by phrase annotation, because it's not only efficient and also effective. You can give you directly the phrase by phrase time aligned results. So yeah, using MFA to do the prosodic research will make the annotation work much more effective and efficient. Then the discussion. So where did MFA show less satisfactory performance? We already mentioned briefly. The very first part is syllables with a third tone. Then what's going on with third tone? These are some examples from the audios that we recorded involving third tones. As you see on the chart on the right hand, like these 2 syllables, the 3 all refers to third tones, right? So it means paper tiger by the literal meaning 纸老虎. But these third tones are realized in very different ways, although the underlying are all third tone. Third tone, which means it's first following, then raising, we call contour tones. And the tone senti applies within disyllabic word. And once you erase the boundary, no additional process, and also in faster speech, like you have the first 2 third tones get evolved to second tones. So tone senti is a really kind of a complex phonological process. So and the MFA, the input we give them is just a dictionary. That dictionary, of course, say these 3 syllables are all third tones. But so yeah, so that's why they show a little bit less satisfactory performance here, which they need to improve their octosync model to be better picked up the third tone, in particular when this third tone undergoes the tone sending process. And also the second category is syllables with neutral tone. Like this do a complement marker. Neutral tone is the ones that are defocused. It's you don't have to put any stress on a syllable, but only need to give it the same amount of stress when it has to be given for the preceding syllable, which means it's kind of like a contact dependent. And neutral tones are much shorter than other syllables. Like if a syllable is realized as a neutral tone, then this syllable is much shorter than any other syllables. Like you see here, ma, 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 right? The first tone, second, third, fourth, and neutral tone. Neutral tone is really light and short, and which in particular, it poses challenges for MFA to pick up the syllable as well as phrase level boundaries. And functional words. Why functional words? You may think functional words are the words such as composed to content words. Content words, for example, eat. I eat an apple, right? Eat. But is like a functional word. Okay, like classifier, negation markers, adverbs, determiners, prepositions, aspects, and adverbial clause markers. Why function word? That's because in Chinese, function words, if a word is a function word, if it's a monosyllabic word, it's often get distressed. And for disyllabic functional words, it's often the second syllable often get distressed as well. So this is a chart, tells you like this is monosyllabic, like 是, the first row is a copular verb. The full form, you have this IPA here, you see here. But if it's a reduced form, which means ones get distressed, and you see they're realized completely differently. Of course, in the dictionary, what we give to the MFA as input is the full form right? It's not the reduced form. The reduced form is only the speaker, is a kind of a pronunciation variation in the natural speech. So functional words, no matter whether it's tone sending or functional words or neutral tones, are all involving in some distress. Okay, so distressed, hard to be recognized. So this is a big challenge for MFA, and also, as far as we know, from other false aligner tools.
Hongchen, sorry to interrupt. We're running. We only have like about less than 10 minutes left in the whole session.
Oh no.
So
Okay, I'm
yeah,
about
yeah.
to wrap up. Yes.
Okay,
but
just because we want to have time for some questions and stuff.
yes.
So yeah,
So
thanks.
yeah,
Sorry to interrupt.
no
Yeah.
worries at all. So like these four, they are all distressed. Okay, they are all false tone, but what the realization was not a false tone at all, not a full false tones. And then this one, and we mentioned earlier, is suffixation. This phonological syllabification process not only changes the syllable boundary, but also influences the tone and the phonetic realization. And another part is the pronunciation variations. It's like some words have two different ways of pronounce, although one of the way is more like we call standard dictionary way, but the other way is more like a just a natural speech variation. And then for these cases, MFA show much lower accuracy. And then conclusions. Yeah, we did the first detailed evaluation report for both syllable and phrase level, and we proposed a new workflow for how to use MFA generate phrase level annotation. And we give insights on where MFA did not so good. Yeah, and the full paper, if you want, it's here online. And there are some additional resources, which is there are some online false aligner tools. If you want to try out, you don't necessarily need to install the MFA. You don't necessarily need to know how to do command lines. You can just give audio, give a transcript, and they give you the results. And if you want to get to know more MFA, these are some tutorials online. And but you feel free to reach out to me if you have questions. Yeah, I didn't know I take this much time, but yes.
It's
I'm
great.
done.
Thank you. Thank you
I'm
so
done here.
much. Thank you
I'm
so
done here.
much. It's okay. We do have a little time for questions and discussions. Not much, but a little. So Mikola, I see a hand. Please go ahead.
Yeah, thank you so much. Can you hear me?
Yes.
Yes.
Yeah, okay. Yeah, thank you again so much for this lecture. My question may be a bit technical, so I apologize in advance. So I worked on Prosody extraction task in a more commercial, like voice conversion task, like in the dubbing and so on tasks. So one of the recurring problems was a poor prosody extraction quality for acoustic models with shorter context windows. As I remember, MFA uses CALDI acoustic model, which has quite short context window, which is enough for phoneme alignment, but might be not enough for prosody extraction. So my question is, have you noticed similar issues, and have you thought about maybe employing more advanced acoustic models, maybe transformer-based acoustic models such as WAV2VEC or Whisper with a phonemic decoder and a classic force alignment algorithm?
Of course. Thank you for the question. Yes. Yes, we chose MFA. The primary reason was like it's open resource and it's relatively easy to install, and it's like only literally just a couple command lines that they already have a template you can directly put. For those who don't have any programming backgrounds, they can still use it. But what you mentioned, these are definitely going to give much better results. But that's kind of like would pre-require researchers, Prosody researchers know a little bit about programming, but not so many Prosody researchers know that. So, but yeah, but definitely that one would give a much better result for prosody extractions. Yes.
Yeah, thank you.
Grace, we don't see you, but there you. Go ahead,
Hello.
please.
Yes, thank you for the talk. I have two questions. So for the phrase level and alignment, you basically added the dictionary and the transcription. And I wonder do you train your dictionary to generate phrase level
No.
or manually edit it?
So the dictionary was like this. We first did the transcript because the transcript gave you the space in between phrases. And then MFA has a way you input the transcript. They can generate the dictionary based on this transcript for you. So the dictionary at the end would look like, for example, 4 syllables, like which student, which will be 4 syllables in Mandarin Chinese. And then in a dictionary will be which student as one dictionary entry. And then the key of this entry, the values of this entry will be each phonemes one by one, which actually
Okay.
consolidating all the 4 syllable dictionary values together. And then, so that's, yeah.
Yes, yeah. So the difference between the phrase level and the syllable level is basically the dictionary that you trained.
And
the
also,
dictionary trained
yes,
is based on the transcription that you get, whether it's on the syllable level or the phrase level.
yeah. So this gives
Yeah.
the Prosody researchers much flexibility how they
Yeah.
want to construct their transcript. Because sometimes, for example,
Yeah.
I'm primarily want to look at WH phrases, then I construct that. But some people might want primarily look into the internal verb phrase, or whether verb phrase and adjunct phrases has prosodic boundaries there. They can also construct. It's like much easier for them to construct the dictionary. The transcript. And once you have the transcript, it's easier to do the dictionary.
Yeah, I think that's a really clever way to change that. Yeah. My second question is very short. So have you compared your trained MFA model with other existing MFA Mandarin models and to see whether your one
I want to clarify. I didn't train a model. I only did the dictionary and the transcript. The autistic model, I still use MFA.
Use the MFA one.
Yes.
Okay.
As far as I know, MFA recently actually released a dictionary, including which accommodated the suffixation.
Yes, I think so.
So you already kind of give you the way to handling this resyllabification process. Yeah.
Yeah. Okay. Thank you.
Hussein.
Hello, actually, I thank you for this marvelous session. It's very nice that it's part of my work in my PhD here in India. My question is of two different parts. The first part, actually, I am working on phonemes and on only the segmental features on Pratt also. So the first part of my question that I am working on the variations of English language spoken by the Arab people and compared to the native English. For example, if how they speak they pronounce the phonemes in English and how exactly is in the native English. So here I want to know how exactly that you can come into analysis and finding that this phoneme is equal or nearby or somewhere else than the other phoneme pronounced by the native speaker. And in the same time also in that qualitative comparison of my work, I want to know in which theory that I can use. For example, they are saying that the native speakers like Chinese native speaker or Arab native speaker or whatever, he has too much influence of his mother language on English language. So the phonemic production of English is coming differently. So actually I want to know how exactly I can figure out because I am working only on the frequencies, and also I'm working on the explaining the spectrograms. And based on that, actually, I want to know exactly how can I judge that these phonemes are equally pronounced to the natives, or is different than the natives, and it is equal or normal to the native Arabic, for example, and which theory that I can use in this one. The second part of my work is that if I am working on consonants in and also in segmental features, this is what I am speaking now. I was speaking was about the vowels. Now about the consonants. When I am working on the consonants, how can exactly work on the segmental features regarding the consonants on the same way? So, and also what kind of theory that I can use? These are the two parts, and thank you very much.
Okay, I will answer the question briefly, but if we want to discuss in detail, feel free to email me. So as far as I know, for the phonemes level, if you want to compare a phonemes level, you definitely need to have this like non-native speakers recording and native speaker recording, and then you have the alignment results at the phone level, and you extract the phone level. Often we call the VOT. VOT is the voice onset time. So you compare for each phones, you see the voice onset time difference there. That's one, like there's one comparison features. And then of course you have other comparison features to see, for example, this how this voice onset time is primarily for consonants. But then for vowels, then you need to extract these vowels. There's specific features on vowels, but then we call if I recall correctly, is called F0, F2. It's about related to pitch. And then you compare,
F0 and this one.
Yes.
F0 and this.
Yes, you compare these ones, and then you extract if it speakers like native speakers, and then you should converge the VOT time or voice onset time as well as these pitch features there. But as regard to which theory you want to use to analyze it, I would say there are so many theories in acquisition literature, which is about whether the voice to be whether you will transfer your phonological knowledge from your first language to your second language or not, or whether it will be influenced by other languages. So these are all the different series that you can further look into literature, but I don't want to give you like a specific theory because I haven't really studied the phonology acquisition for a while. So I don't want to give you false information before you see the literature, most recent literature on that. Yes, and sorry for it go over a little bit time. It was great to talk to you guys, and feel free to email me. I can type my contact information in the chat as well. Yeah, feel free to email. I'll keep in touch, but do hope to see you at other occasions like NYI events. And thanks, Vincent. And I have to say, I didn't see your messages until because
No, you're totally fine. Yeah,
I have two screens. I was just looking at this screen presenting, and the other screen, the chat, I somehow on the second screen, and I didn't.
yeah.
Okay, but yeah, thank you for the reminders. But
Yeah,
you could have just unmute and say Hongchen
yeah.
stop.
No worries at all.
Oh
But
yeah.
yeah, so thank you very much for the amazing talk. Thank you everybody for sticking around for the discussion, and yeah, looking forward to seeing you in the future. We really appreciate you being here. So
Yeah, thank you for all being here, and have a good weekend.
yeah,
Bye.
you as well.
And Happy New Year.
Yes.
Bye.
Right. Take care, everyone. Have a good day.
Take care.
See you
Bye
soon.
bye.